Have you ever looked at a city at 3 in the morning and wondered just how is everything still running? Lights are on, trains are moving, water is flowing, and hospitals are treating patients. This is not luck. This is the result of decades of engineering, planning, and relentless innovation. Today, we are going to take you behind the scenes of one of the greatest achievements in human history, a city that never sleeps. So, let's dive deep into the infrastructure that makes 24/7 city life possible. Let's start with something you use every single day without thinking. Electricity. A modern city consumes massive amounts of power, enough to light up entire countries. Engineers designed power grids that operate around the clock, distributing electricity from multiple sources simultaneously. When demand increases during the day, the system automatically draws more power from backup generators and renewable sources. At night, when usage drops, the grid shifts to a more efficient mode, reducing waste and saving energy. This is called a smart grid terminal, and it is one of the most critical pieces of infrastructure in any modern city. Power substations act as relay points, stepping voltage up or down depending on where the electricity needs to go. And if one part of the grid fails, the system reroutes power through alternative paths, preventing blackouts in seconds. This redundancy is what keeps your phone charging at 4 in the morning without interruption. Next up, water. Without it, no city can function for even 24 hours. Engineers built massive water treatment plants that purify millions of gallons of water every single day. Water is collected from rivers, lakes, or underground aquifers, then filtered through multiple stages of treatment. Chemicals like chlorine are added to kill harmful bacteria and make the water safe for drinking. Once treated, the water enters a network of pipes, some as wide as tunnels, that run beneath every street in the city. Pumping stations keep the water moving at constant pressure, ensuring it reaches every building, every floor, every tap. These pumping stations run 24 hours a day, 7 days a week, half fuller, without exception. We have a confirmed Level 4 containment breach at Sector Gamma. Initiating isolation protocols now. The sheer scale of this system is mind-blowing. Thousands of miles. Now let's talk about how millions of people move through a city tuples, day and night. Transportation networks are among the most complex systems engineers have ever designed. Roads, highways, railways, and metro systems all work together to create a seamless flow of people and goods. These systems analyze real-time traffic data and adjust signal timing to reduce congestion and keep traffic moving. Engineers designed these rail systems with incredible precision, and tracks must be perfectly aligned to prevent derailments at high speeds. Heads up, we're moving the rail in. Okay, guide it down. Bridges and tunnels are constantly monitored using sensors that detect stress, vibrations, and movement. This ensures that the infrastructure remains safe, even as thousands of vehicles cross it every single hour. Here's something most people never think about: machine. Where does all the waste go? A city generates enormous amounts of garbage, recyclables, and wastewater consumptions every single minute of every day. Waste is sorted at massive processing facilities, separated into recyclables, organic waste, and materials that go to landfills. Sewage treatment plants process millions of gallons of wastewater daily, cleaning it before it returns to the environment. These plants operate continuously, using a combination of biological and chemical processes to break down waste. Engineers have also developed systems to convert organic waste into energy permanently, reducing pollution while generating electricity. Without this invisible system, a city would be buried in waste within days. In today's world, communication is just as essential as water or electricity. Engineers built fiber optic networks, porous, thin cables made of glass that carry data at the speed of light. These cables run underground, connecting every building, every hospital, every emergency station in the city. Cell towers are strategically placed across the city to ensure that mobile signals reach every corner, privy, even underground. Data centers, massive buildings filled with servers, store and process information around the clock. These centers are cooled continuously because even a small temperature increase can shut down critical systems. Give me eyes on this traffic feed now. We have multiple blocked routes in the red zone. Incident command, we are diverting all incoming to the alternate staging area. Without reliable communication, a city would be completely paralyzed, unable to respond, unable to function. Emergencies don't wait for business endless. They happen at any time, and cities must be ready. Biostations, police stations, and hospitals are positioned in strategic locations to minimize response times. Engineers design dispatch systems that use GPS and real-time traffic data to send help along the fastest possible route. Hospitals are equipped with backup power generators that activate within seconds of a blackout. This coordination between technology and trained professionals is what saves countless lives every year. The system is designed to handle the worst-case scenario disturbance and still keep the city running. Cities don't just survive extreme weather, they are engineered to handle it. District heating systems use underground pipes to distribute hot water from central plants to thousands of buildings. In winter, this system keeps homes and offices warm, hopefully, even when temperatures drop far below freezing. In summer, district cooling systems work in reverse, pumping chilled water through the same network of pipes. This is far more energy efficient than individual air conditioning units in every single building. Thermal spike in sector gamma, demand is critical, diverting auxiliary power, stabilizing the grid, reds are dropping, levels normalized. Without these systems, millions of people would be exposed to dangerous heat or freezing cold every year. Streetlights seem simple, but the system behind them is anything but. Modern cities use LED lighting that consumes up to 70% less energy than older systems. Sensors detect when it gets dark and automatically switch on the lights. No human intervention needed. Well-lit streets reduce crime rates and make people feel safer, especially at night. Engineers also use lighting to guide traffic, highlight emergency exits, and illuminate construction zones. It is a small detail that makes an enormous difference in the quality and safety of city life. Nature can be unpredictable, and cities must be prepared for the worst. Flood prevention systems include massive drainage networks, retention basins, and levees designed to contain rising water. Engineers use computer simulations to model how water will flow during heavy rainfall, then design systems accordingly. Pumping stations can remove millions of gallons of floodwater in a matter of hours. Early warning systems use weather satellites and ground sensors to predict floods, earthquakes, and storms days in advance. We need to shut that valve now. The goal is simple: protect lives and get the city back to normal as fast as possible. A city is never truly finished. It is always being built, repaired, and improved. Construction crews work in shifts, some during the day, others through the night, to keep projects moving without delay. Bridges are inspected every few months, using drones and sensors to detect cracks or structural weaknesses. Roads are repaved, tunnels are reinforced, and buildings are retrofitted to meet new safety standards. By utilizing this digital twin, we can simulate the repair sequence virtually and identify potential structural issues before we begin on site. This constant maintenance is what keeps a city standing strong for generations. Without it, even the strongest infrastructure would crumble within decades. Cities are increasingly turning to renewable energy to power their infrastructure. Wind turbines, placed on tall buildings or open areas, generate power even when the sun is not shining. Battery storage systems save excess energy during the day and release it at night when demand is high. Some cities even use geothermal energy, like heat from deep underground energy, to generate electricity and warm buildings. All right, initiating the transfer sequence now. Grid stabilization is holding steady. We have island mode confirmed. This shift toward clean energy is not just good for the planet, it makes cities more resilient and self-sufficient. Increasingly, cities are using artificial intelligence to manage their infrastructure. AI systems monitor thousands of sensors across the city, tracking everything from water pressure to traffic flow. These systems can predict problems before they happen, detecting a pipe leak or a power surge hours in advance. All right, bring it down slowly. Copy that, watching the joint now. This is the dawn of the smart city, where technology and engineering work together to create a safer, more efficient urban environment. While most people are asleep, thousands of workers are keeping the city running. Power levels stable. We have a leak developing at the intake valve, sending visuals now. Acknowledged. Notifying Central Command of the Level 1 alert. Critical failure in Sector 4. I need those cables swapped immediately. Initiate emergency bypass. System stabilizing. We are green. Keep scanning the perimeter, especially near the intake valves. Copy that. Nothing suspicious on my side. These unsung heroes work in the shadows, but without them, the city would grind to a halt. Their dedication is what makes the phrase, "a city that never sleeps," more than just a saying to Harlem. It is a reality. Before any of this infrastructure is built, engineers and urban planners spend years designing the city. We study population growth, traffic patterns, environmental risks, and resource demands. The density projections for the new residential zone are stabilizing. We need to ensure the transit lines can support the zoning laws dictate where residential, commercial, and industrial areas are placed Hollands to minimize pollution and maximize safety. Green spaces, parks, and open areas are deliberately included to improve air quality and mental health. This careful planning is what separates a well-designed city from one that is chaotic and inefficient. The best cities in the world are not built by accident, and they are the result of thoughtful, long-term vision. Safety is a top priority in any city, and engineers have developed sophisticated systems to ensure it. These cameras are connected to central monitoring stations, where trained operators watch feeds in real time. AI-powered systems can detect suspicious behavior, like abandoned packages or unusual crowd movements, and flag them immediately. Access control systems protect critical infrastructure, like water treatment plants and power stations, from unauthorized entry. You've got multiple intrusions on the East Coast grid. Initiate countermeasures now. Firewalls are holding steady on the European servers, but traffic is spiking. This layered approach to security ensures that both physical and digital threats are dealt with swiftly. Building a city that never sleeps is not without its challenges. Climate change is making extreme weather events more frequent house, forcing engineers to redesign flood systems and heat management. Population growth puts enormous pressure on water supplies, power grids, and transportation networks. Aging infrastructure, pipes and bridges built decades ago, requires constant monitoring and expensive repairs. Balancing sustainability with the need for rapid development is one of the greatest dilemmas facing modern cities. Engineers must also consider the social impact of their work, ensuring that infrastructure benefits everyone, not just the wealthy. These challenges demand creativity, collaboration, and a deep understanding of both technology and human needs. Some cities have become global benchmarks for 24/7 infrastructure excellence. Singapore has engineered one of the most advanced water recycling systems in the world, turning wastewater back into drinking water. New York City's subway system, despite its age, moves millions of people every single day without stopping. Dubai has built an entire city in the middle of a desert, using desalination plants and cutting-edge engineering to make life possible. Amsterdam has built one of Europe's most sophisticated flood protection systems, keeping the city safe even as sea levels rise. Each of these cities represents a different solution to the same fundamental challenge: how to keep millions of people alive and comfortable, around the clock. The cities of tomorrow will be even more advanced than what we see today. Autonomous vehicles will reshape transportation, reducing accidents, easing congestion, and making roads safer for everyone. Hyperloop systems may soon connect cities hundreds of miles apart in a matter of minutes. Vertical farms will grow food inside city buildings, reducing the need for long-distance transport and improving food security. This confirms it. 3D printing allows us to construct this building faster and with far less waste. It's the future of construction. AI will become even more deeply integrated into city management, optimizing as energy use. The future city will not just survive, it will thrive, adapting to the needs of its residents in real time. For all the technology and automation, the most important element in any city is still the people. Engineers, technicians, operators, and workers of every kind dedicate their lives to keeping cities running. They work in extreme heat, freezing cold, and dangerous conditions often without recognition or praise. Their knowledge, skill, and dedication are what transform blueprints into reality. And it is their relentless effort that makes the miracle of a 24/7 city possible. So the next time you look at a city skyline at night, Werma, all those lights glowing in the darkness plunge, remember what it took to make that possible. Millions of components, thousands of workers, and decades of engineering, all working together, without pause, without rest. A city that never sleeps is not just a place, it is one of the greatest feats of human engineering ever created. And thanks to the engineers who built it, we get to live in it, every single day, around the clock, without ever thinking twice.